So finally we have this one, which is very similar to the one before, but with a couple differences. One difference is that they're using the letter r as the dummy variable of integration. Of course, that's inconsequential. But another difference is that the bottom bound is 6 instead of 1. That's also pretty much inconsequential. But the other difference, which is not inconsequential, is that the upper bound is not simply x, it is x squared. So that makes a big difference, right? In the last problem, when it was just an x, it's like the way that it worked out is basically the derivative canceled with the integral, and you just got the function that you had on the inside, right? It just worked out to be the function that was on the inside because the upper bound was simply x, and so that's just like canceling out the derivative effectively. But it's not like that when the upper bound is x squared. It's a little bit more complicated. It involves the chain rule, but we can still figure it out in the same way. So here's the idea. We can avoid having to figure out the antiderivative by just calling it something temporarily, and then it turns out we won't ever need to figure it out. So what I mean is, if you wanted to do this the long way, you'd have to figure out, okay, what is the antiderivative of 6 plus r cubed? What function has that as the... I don't know. I'm just going to call it capital F. And capital F has the property that when you take its derivative, it's the square root of 6 plus r cubed. Or square root of 6 plus x cubed, or whatever the letter is. Whoops. Damn, hold on. Just broke my setup here. Alright. So yeah, so f has that property. So there you go. So that's what I need, right? So that means h of x is equal to that, and then you plug in the bounds. Now again, f of 6 is just going to be some number, right? I don't know what f is, and so I don't know what f of 6 is, but it's probably like 17.58. I don't know. It's just a number, right? So that means that when I take the derivative, h prime of x, it means that this term is going to disappear, right? Because it's just a number. It's some number. I don't know what. It's just some number. So it's gone. Because the derivative of any number is 0, right? It doesn't matter what it is specifically. But then now let's take a look at the important term. So the important term, right? It's f of x squared. So if it was just f, then it would be f prime. But since it's x squared on the inside, we have to invoke the chain rule, which says we must multiply by the derivative of that thing, right? So we must multiply by 2x. And then we know what f prime of x is, right? F prime of x squared, rather. F is the antiderivative of the square root of 6 plus r cubed. So f prime is the square root of 6 plus r cubed, right? So it's x squared plugged into that, the square root of 6 plus the input cubed. So it turns out that h prime is, I'll put the 2x in the front, 6 plus x to the 6. By the way, that's x to the 6, right? Because x squared cubed, if you think about that, that's x squared times x squared times x squared. And so 2 plus 2 plus 2 is 6, right? Or you can just remember that the exponents multiply together. Okay, so there you go. So that's h prime. So that's how you can, yeah, those are really bad. I'm going to do those again.